Great to be back at Technology Live. It's been a number of years. I think the last time it was at the Haymarket. Great to be doing this. Thanks to you. Thanks everybody for coming. I've got basically an overview of the company, then an overview of the product that we're going to go through, and then we're going to talk a little bit about our roadmap, and then we'll go into like a full demo of QuantaStor. We're going to go set up a complete storage cluster right here on the as part of the presentation. It's Technology Live, so we should do a live demo. So that's what we're going to do at the end. And as Fred was saying, jump in with questions anytime you have them. I'm happy to just field those as we go along. I've got Darren Shepard as our Director of Sales for EMEA and Nordics with us. And I've also got Joshua Blake, who's one of our lead solution engineers for EMEA. So if I can answer it, I've got plenty of backup with me. So we'll do our best to answer your questions today. So a little bit about the company to try to kick things off. There we go. So I started the company back in 2010. I'd been in the storage industry for about a dozen years then, most of that at Veritas, a little time at Citrix. And the thing that I noticed was that all of the great innovations that were happening on the compute side to really bring a hypervisor to market with Zen, where I was working on Zen server there for a little while, and all the great things that VMware had done to virtualize computers hadn't really been done at all on the storage side. There were some storage virtualization technologies that we had built, but back in the late 90s, we had this vision at Veritas of utility computing, that you could just get storage like utility, like power delivered to your house. And there just weren't all the great technologies that we have today, like containerization, to really make that happen. So there was this idea of multi-tenancy, of highly flexible storage. And the story of OSNEXUS is really about getting to that utility computing vision and the type of cloud computing and kind of integration of cloud computing and storage that we do today. So 2010, the company starts. We find our first market fit pretty quickly. IBM is going into the cloud. They acquire SoftLayer in 2013, and they need a way to move a lot of NAS systems, a lot of NetApp in particular, into the cloud, into their data centers. And QuantaStor is one of their key vehicles for doing that. So IBM is an early adopter of software-defined storage because it's critical to their strategy of moving their customers into the data centers and into the cloud. So we found very quickly, given all the types of requirements that IBM customers had as we started growing rapidly from 2013 through that big transition for IBM, a lot of new technologies were needed to really serve the needs of those customers. And one of the key things we found is we needed to make sure the product worked across all the data centers. You need to be able to replicate your data from Dallas to Seattle to London. And so we needed it such that all of your QuantaStor appliances needed to be able to work together in a hybrid way or in a hybrid cloud type fashion, from on-prem to into the IBM cloud and then between those data centers. So that became like a requirement very early on because we were sort of really born in the cloud from all these requirements of IBM customers. And along the way, we really started adopting more open source technologies like ZFS and Ceph. These are super powerful file systems, and ZFS and Ceph have now been around for over a decade. They had some really key technologies that helped us meet the needs of those IBM customers and really set the stage for the next phase of the company and our next major product fit and market fit. And that led to our first deployment over 25 petabytes in 2018. That was with another cloud service provider, and a lot of new partnerships that followed on there. And from there, we've gotten into some really exciting technologies with composable disaggregated infrastructure integration, a lot of work that we've done with Western Digital, a lot of work that we've done with Supermicro as well in the area of dual-ported NVMe, highly available systems. And that takes us to today, where we're working on a lot of advanced multi-tenancy features for cloud service providers. So that's kind of a quick tour of, from where we started to where we are today. And yeah, you guys got it right. It's Open Storage Nexus. And when I was trying to come up for a name, for a good name for the company, the idea really was about let's make a storage platform like a hypervisor that works on Linux, and we need to bring together all these really great technologies that are in the open source, and so that just kind of stuck. So and the domain was available. It's kind of hard to find available domain names, and so that combination of things just brought the company name together. So the next bit is kind of a quick, what is QuantaStor? So in this slide, we're just going to go through kind of what are the key features of the product, what are the things that differentiate it, and then we'll go into some more detail on some of these points, and then we'll be getting into the demo. So the thing that's really core to QuantaStor that makes it unique is our grid technology. And as I was mentioning earlier, when we started doing our first deployments in the IBM cloud, companies using QuantaStor started deploying them in multiple data centers. We knew we needed to link these systems together so that they wouldn't have to go and manage little silos of storage. So one of the early goals in the company was to eliminate storage silos, because that is a huge cost center for IT organizations. If you have 5 different storage products and they're instances of these clusters throughout your environment, it's difficult to just keep track of all the passwords, keep track of all the different security policies that you've applied across these systems, keep track of how much free space is there. So that becomes a lot of wasted space in most organizations. And with the grid technology, you're managing everything through a single pane of glass, no matter where you've deployed it. And that just makes it easy for an organization to manage their storage with a lot less staff. You can go and manage 30 petabytes of storage with QuantaStor and have one person doing that part-time. And that's a huge change versus the way storage was managed in the past. So the next thing that we really aimed to do was to really make storage flexible from a hardware perspective. Up until around the time that we started 2010, everything was still proprietary. But the idea of software-defined storage was a couple of other companies out there that were getting started in that space, but everybody doing anything as primary storage, it was all on proprietary type systems with proprietary hardware. And today with QuantaStor, we've done a ton of work to just make the platform super flexible to work with a variety of different hardware. And it goes beyond just saying, hey, the software works with that hardware. We integrate it such that everything, when you pull like a power supply out of the back of one of the a QuantaStor server or server running QuantaStor, it'll immediately generate an alert saying that you no longer have the power redundant. If the thermals get over, on the CPU or the motherboard, all those kinds of system internals, we're monitoring those, and we're also showing those in the UI, so you can see exactly where the media is located, the front bezel of the system. So all those things that you would come to expect from an enterprise system like a NetApp or EMC, those were key to the product development of QuantaStor as well, because it needed to be a replacement for those other products without sacrificing that level of hardware integration. So today we cover, in terms of integration, there's 88 different servers that are integrated into the UI, where it'll auto detect and just show you the matching hardware when you click on the system. And we're adding more systems to that all the time as Dell and HP and Cisco and Supermicro come out with new systems. This next bit is really about, well, if I'm trying to eliminate the complexity of dealing with storage silos, what about just different types of storage? If I have to buy 3 different products to solve my needs for file, block, and object, that also creates all kinds of security problems in terms of trying to manage it, and the differences in security capabilities between different products. So having a platform that can do all 3 protocols within the system just makes it so that IT organizations can do a one-stop shop, get all of their all of their storage and deploy it on different hardware that matches the needs of their workloads, and deliver all those major protocols: NFS and SMB for file, iSCSI and Fiber Channel for block, and S3 for object. Security is such a huge focus of what we do at OSNEXUS. So we've integrated QuantaStor with multi-factor authentication, LDAP for single sign-on and Active Directory. We're almost done with our FIP certification. That's been filed with NIST back in 2020. It's just, those are one of those government processes that can take a long time. And we've made sure that the product is compliant to a bunch of other security standards like 800-53 and 171 and HIPAA compliant. All of these things make it so that IT organizations and healthcare and government can use the product and lock it down per the requirements of their environment. We talked a little bit about the Open Storage Foundation. The product uses open source file systems underneath, and the reason why we do that is we're really dedicated to having a product that is going to be innovative for decades to come. And one of the things that we've seen in the storage industry is there's typically sort of a peak and trough to the innovation cycles that are there with file systems, and that happens with open source file systems as well, but they are much longer in terms of their time scale. And we have customers in heavily regulated industries where they need to keep their data and manage that for 50 years because they need to be able to look at, the designs, the engineering designs for some of their systems, and we want them to have a solution that's going to be innovating on a long-term scale. And so we are a member of the Ceph Foundation, a member of the OpenZFS Foundation. We integrate those technologies, but we eliminate the complexity of those technologies so that anybody can go set up and deploy a QuantaStor system, as you'll see when we get to the demo, and have all the support behind it, so they don't have to be an expert with any of those technologies. And we kind of normalize all the terminology to terms that are used by the Storage Networking Industry Association, so that it's broadly understandable from people with an enterprise storage background. So we use terms like storage pool, storage volume, network share, things that are really make it intuitive the minute that they start using the UI. And so a little bit more on the grid technology. I put the little OSNEXUS logo on the front of these servers here so you know kind of where the operating system is installed. But the installation of the OS is just a real basic install. It's Linux-based, so we've kind of eliminated all the complexity that we could out of the install process. And so when you install QuantaStor, you get all of our commercial software along with a base Linux OS when you install, and it's all just installed at once from our ISO image from our website. It asks just a few handful of questions, like what time zone are you in, what's your keyboard layout, and what do you want to name the server? And the last thing it asks is which device do you want to install the OS onto? So after those 4 questions are answered, the system reboots, and all the rest of the management's done right through the web UI. And as you add more of these systems into the grid, they show up in the web UI, and everything's managed from any of the boxes in the grid. That's one of the really cool things about having this distributed grid database, is that you can log into a box there in Tokyo or a box in Seattle, and you see the whole entirety of the grid, and you can go provision storage from everything that's within the grid. And then you can start setting up things like remote replication to replicate data between different sites. And now you've eliminated the whole problem of storage silos. When you log in to this particular grid, you can see that we have 7 pools of storage. We can go and provision file and block storage for different people in our organization just by logging into the grid. So that's a key part of just making storage management really easy for larger organizations and small ones too. So this is a quick look at what the UI looks like. We're going to do a demo later, but I just wanted to point out this bit over here where you can see the front bezel of a Dell storage enclosure and the individual drives. This is an example of how we've integrated all of the slot mapping for all of these various units. I mentioned we've got about something over 88 different servers. We have about something like 80 to 100 JBODs integrated with the system as well. And we have a really pluggable configuration file where we can just go and edit it and add more systems on the fly. So that just makes it really easy for us to certify and add more systems in there. And when a drive goes bad, this green box, it's kind of hard to see on this at this size, that represents the drive which switched to red. You'll see a little icon appear on there indicating that QuantaStor has activated the LED beacon. And now your remote hands in your remote data center can just go into the data center and very easily identify which drive to pull and replace. And I'll get into our zero-touch maintenance stuff here in just a little bit. This is a little grid dashboard that shows you, the servers that are in the grid, some thermals, CPU load, power supply state, that kind of stuff. So that's just more of a nice way to kind of get a quick glance at all of the systems in the grid from a hardware perspective. So next, I'm going to talk a little bit about scale out versus scale up. The scale out storage really got popularized by Isilon back in the day. And it's a game changer because it really lets you achieve these scales of in terms of capacity and performance that are just not possible with scale up. But one of the things that we found is that there's still a lot of demand for scale up. And the reason why is it's much more cost effective, especially for more compact configurations. If you're under a petabyte, which is very, very often the case when we're talking about block storage for virtualization, the scale up configurations are where it's at. You can build those for much lower costs and a much more compact, like 2U footprint than typical for scale out, with a lot less CPUs. And so QuantaStor supports both of these in the same product. So our customers can deploy clusters like you see on the right, and that's using OpenZFS technology underneath. Or they can do clusters like you see out on the left to do like scale out object storage and scale out file storage. So they get the choice. And so we can go and match basically a solution that matches their workload and what their budget is, and can switch between these two and have all of these managed within the same storage grid. Oh, we've got some questions in the chat. Let's see what we have here. All right. Yeah.
Yeah, so we've got Bertrand. Bertrand is one of our guests from France, asking, do you support CSI? And well, we had Joshua replying.
Yeah.
So, yes.
Yeah, those are great questions. The CSI and the Cozy are for those that are unfamiliar, are plugins for Kubernetes. And one of the great things about using the open source file systems underneath is that we get this whole ecosystem of plugins, like the Cozy plugin for Ceph. So yeah, we have support for both CSI and the CSI is a block storage module for Kubernetes. So when you're running containers and you want them to have persistent state, they will go and get a piece of block storage from the underlying system, in this case, like a QuantaStor scale-out cluster. It'll go there and grab a piece of block storage and then access that over what's called the RBD protocol. Or in the case of object storage, can use the S3 protocol to provision a bucket and start writing data to that. So yeah, integration through both of those, we're kind of getting for free because we're part of this greater ecosystem of open source development at the file system level. All right.
A question about this scheme. In the scale-up architecture, what is the minimum number of controller? I think you need 2 controllers at least.
That's exactly right. We need 2 controllers for HA. And if one controller is turned off or goes offline, like here, you've got a large pool of storage. If this controller goes offline, the pool would be then immediately managed by the other node. You can also have as many pools as you want. So even though there's two controllers here, you could have 4 pools or 3 pools. And if the controller head node is turned off for a given that is managing any number of pools, those would just be moved over to the other node automatically.
But in this case, the pool are JBOD chassis connected to both controller, or 3 of them are connected to the first controller and the other 3 to the second controller?
That's a great question. They're all simultaneously connected to both controllers. And so we, like all of our deployments, we direct cable all of the head nodes to the JBODs because that's the most reliable route. If we have a cable problem, we know exactly which JBOD it's affecting. There's these other techniques that have been used a lot in the past, which are still viable cabling techniques like cascading, but we generally avoid those techniques and direct cable those. And so with 6 JBODs, you can direct cable those with 3 HBAs. And so we like to kind of set that as the upper limit. It's not a hard limit, but in a practical sense, you generally don't want to be building clusters with over 600 devices. And today with 20 terabyte drives, that's 12 petabytes. So technically you can take these scale up clusters to really, really large sizes. In practice, we typically don't deploy more than about 4 of them per customer, but they work great at 4. I know they work great at 6 as well. So it's the direct cabling just really simplifies the configuration, the hardware deployment configuration time. What are we using for systems management? SMIS, Swordfish. Our grid technology has a REST API so that customers can come in and talk to any node that's in the grid and talk to that. We do have an SMIS module, but it's not published because we really haven't seen any demand for it. There's some interesting things that you can do with System Center Virtual Machine Manager on the Microsoft side with SMIS. So we're looking into potentially integrating that for Hyper-V users. Swordfish is sort of a add-on to the Redfish system that is part of the SNEA standards group. So have we put a Swordfish plugin together? Not yet. We've been looking into it, but again, it's also one of those things that we just haven't been seeing a lot of demand for yet, but we've got our eye on it. And I think that eventually we will have a Swordfish plugin. Proprietary
Sorry,
vendor
Steven. Sorry,
yeah.
Steven, just to jump in. I wanted to make sure everyone knows we do have a representative from SNEA here today, Alex McDonald. So if anyone has any questions, particularly about Swordfish, for example, Alex will be able to address them now or later. I don't want to take time away from Steven's presentation, but just in case, in terms of making everyone aware, full disclosure, Alex is representing SNEA here today.
Hey, Alex. Great. In terms of proprietary vendor interfaces, we've got like a Docker volume driver that you can get from the Docker website. We've got an OpenStack Cinder module. So we've done integration with a number of the other, different systems that are out there that have plug-in systems for storage modules. So on the VMware side, we've done VAI. We've also built a VASA module. So yeah, there's some proprietary vendor interface stuff that we've done. On the Veeam side, that was just more about just certification testing. So there wasn't a plugin to go build for them, but we've tested and verified QuantaStor with Veeam on using their scale out backup repository system that uses QuantaStor. We set up QuantaStor NAS as the performance tier, and we set up QuantaStor Object as the archive tier.
Steve, there's a question that Roy's asked actually, which is what, if anything, are we doing about environmental sustainability, ensuring that the storage is minimizing the impact, which is a pretty good question to.
Yeah, there's a lot of technologies that were looked at into like spinning down hard drives and things like that in the past. We're not really doing anything to try to like spin down hard drives, but we keep up with the latest in the hardware technology that comes out from the various vendors like Western Digital and Seagate, and work closely with them to go in and adopt their latest technologies, NVMe over Fabrics being one of them. And so we look forward to kind of investigating more technologies in the future that can help us, bring down the energy costs of maintaining storage. Yeah, so I don't know if there's anything very specific that we do that helps reduce energy consumption. I would say the way that we're really helping in that area is being able to do more with the hardware that you have, being able to do file, block, and object in one system, so you don't have to deploy 3 of them. So those kinds of things really help in making the overall system more efficient. Yeah, do we use data sharding and erasure coding in your infrastructure? So the scale out side of things is using erasure coding or replica, depending on what the customer wants to do. And you can choose any K plus M. So with erasure coding, you've got a certain number of data blocks as a ratio to some number of coding blocks. As a minimum, we always require that you've got 2 or more coding blocks to protect the data. But you can do, 4 plus 2 or 12 plus 3. You can do any combination of data to coding blocks. And on the scale up side, we're using software RAID that has bit rot protection and things like that. So there's 2 different styles of cluster deployment that you can do within the product that way. So this goes into a little bit on just kind of a visual way where you can see, a grid growing to include more pools. Some of these being scale out, like you can see here where the pool is spanning all the storage across a large number of servers. And then over here where you've got 2 head nodes plus the pool of storage in the JBODs. This just really makes it a lot easier to eliminate those storage silos and keep track of where all your storage is at and maintain it. Because when you set up call home alerting, you've got one place to go set that email address. When you want to go set up a new admin inside the grid, you just do that once and it applies everywhere. Same kind of thing for like block storage. Whenever you provision block storage, you have to tell the system about the IQN of the host that's going to go access the iSCSI device or NVMe over Fabrics device. And if you've got lots of different systems, you're kind of constantly entering those. But with the grid technology, you only have to add that once. So a lot of the things that, that are a headache with storage silos is that you just have to repeat doing things over and over again for each cluster. But when you're in a grid, those things become single actions that you can even automate.
Steven, I've got a question on your grid.
Yeah.
Just assuming since one is based on ZFS, the other is based on Ceph, those environments are still separate within the grid. You're not sharing anything in between them, but you're pooling within that grouping, your scale up or your scale out.
Yeah, every single node is running the core QuantaStor service, and that service communicates with all the other nodes in the grid. There's an elected primary node where the events are routed through to keep all the other nodes up to date. But yeah, these clusters are separate clusters. If you turn off nodes within one cluster, it's not affecting any of the other ones. So yeah, the ZFS and Ceph usage is completely separate. We're not stacking those 2 things together. But QuantaStor has some cool things that span the grid. Like you can set up what we call our network share namespaces. So if you access one of the nodes that's part of this scale up cluster, it can also be advertising shares as part of a namespace that are from these pools that are scale up. So the global namespace feature is really nice for being able to take all of your file storage within the grid and make it appear like it's coming from all the nodes at the same time, even though
you've got a global namespace that's crossing Ceph and ZFS.
Yes, yeah, where you'll go in and you'll see individual shares, and those shares could be from ZFS, from Ceph, and you can make those shares appear as if they're coming from all the different nodes. So we're using the equivalent of like Microsoft DFS underneath and some NFS redirect technology to redirect the client connection to the right node.
Okay.
Yeah. You can also set up remote replication. We also have a backup policy feature. So you can have a NAS pool doing backups to an object storage pool within the same grid, or even outside of the grid. So there's some ways that you can interconnect to move data and copy data between different styles of clusters, so meaning scale up can copy data to scale out and vice versa through these backup policies.
And what are you doing with replication that's cross the technologies? Anything, or is it just an orchestration layer?
Yeah, we call it our backup policy, and you create these right within the web UI, and
Okay.
you
Not
can
replication, but backup policies.
Yeah, and they are doing replication, but it's not block level incremental. When you're crossing technologies, you don't get that benefit
Correct.
of being able to say, okay, it's just these 3 bits that were changed in this large file, only transfer that. When it's crossing technologies, we have to go scan and figure out, okay, which files have been modified, and then just send those change files. And that's not nearly as efficient, especially when you're talking about data stores with millions and millions of files.
Correct.
Yeah.
Okay, thanks.
Yep. Yeah, great question. As you start to, getting into more and more rack scale deployments, maintenance becomes a really important thing to try to make easy. And so over the years, we've added some things like our zero touch maintenance feature. And what this is all about is just doing the right thing when the IT person removes the bad drive and puts a new one in. It's such a simple thing, but it makes a big difference in maintaining rack scale clusters. So what QuantaStor does is when it detects that a drive is bad, it marks it. It starts by activating the LED beacon. And if you log into the UI, you'll see the drive highlighted in red. But it sends a call home alert as well, saying that the drive needs to be replaced. And so the person that's your remote hands at a colo data center, when they go in there and see the bad drive, it's going to be highlighted in the chassis with that beacon light on it. They pull it, put a new one in, and you're done. QuantaStor knows that you put the drive back into the same slot, that you took a bad drive out and put a new unused drive in. It'll automatically take that drive and turn it into a hot spare if that particular node is being used for a scale up configuration, or if it's for scale out, it'll absorb that as a data device back into the scale out cluster. So that kind of smarts of kind of situational awareness of what a drive was being used for, when it was replaced, and what it was replaced with is all part of that zero touch maintenance. We talked a bit about the single pane of glass. We're going to do a demo of setting up a whole cluster here in just a little bit, so you'll see that. But there's no extra software to install. The web UI that you see is on every single node of the grid. And so you can simultaneously log in to any number of nodes in the grid and do management simultaneously. And so there's resource locking happening within the grid, so that, if 2 different people are trying to do actions at the same time, that those things are done in proper order. Do you provide a version of Linux, or do you install on top of it? We do both. Olivier has a question there. From the beginning of the company, we built QuantaStor on top of Ubuntu. And that was because back in 2009, 2010, to use other distros, they just didn't have a modern enough kernel for a lot of things that we were doing in terms of integrating Fiber Channel and iSCSI in those early days. As time has gone on, the kernels have gotten more and more modern across all the different distros, and a lot of the public sector organizations that we work with, they have really standardized on Red Hat. And so a couple of years ago, we really put a lot of energy into getting QuantaStor on Red Hat, and it's available on Red Hat 8 today. So when we install from our ISO image that's on our website, you're installing QuantaStor, but underneath you're getting Ubuntu Linux installed on that system with all of our commercial software on top. but there's also an option where you just install Red Hat and then you upgrade the Red Hat system into a QuantaStor system through a script that we provide on our website. So there's both the kind of like install Red Hat and then upgrade it route, or the all-in-one image that's available from our website.
Another question on there, Steve. Do we support grid? So storage grid, does the storage grid also provide multi-tenancy or at least delegation capabilities?
Yeah, it does. And that's a great question. And I'm going to get into some much greater detail in the last couple of slides. So I'll hold that one for just a minute because we're going to dive right into the multi-tenancy stuff that we're working on today. But multi-tenancy as a concept was very early in the product. We put multi-tenancy features in back in, I think around 2012, 2013. And that was because one of the things I saw when I was at Citrix working on Zen Server and integrating storage arrays into the Zen Server platform was that IT administrators didn't want to put their administrator access credentials into the hypervisor layer. They didn't trust the software package and the people that were managing the hypervisor layer to just take over control of their storage systems. And so that when we were designing QuantaStor at the very beginning, we needed to be able to really put a security model in there that would compartmentalize what you could do with your with a given user account. And so the role-based access controls and early multi-tenancy tech went into QuantaStor very early on in order to help organizations, share resources and be able to do that securely without having a product that has credentials to go into the storage grid to do anything destructive. Let's see, did I get through all those? Yeah, so the cool thing about using technologies like Ceph is there's Ceph users out there that have clusters that are using 10,000 plus devices, and a lot of clusters that are using 2,000 plus devices. So 2,000 hard drives at modern day 20 terabyte drives, you're talking about 40 petabytes of storage with just 2,000 devices. And that's the kind of scale that scale out really lets us get to. And QuantaStor, within the grid, you can manage multiple of those clusters. So instead of it just being sort of like, I'm just going to go manage one Ceph cluster, you can say, well, I just want to manage all of my clusters through a single pane of glass. You can do that with QuantaStor, and that's what lets us get over 100 petabytes under management in a single pane of glass. All right. Yeah, we do end-to-end encryption. We do encryption at rest. That's both hardware and software based. So we integrate with the self-encrypting drive capabilities of modern Flash, NVMe. So Opal and Ruby. You can do hardware encryption with QuantaStor. You can also do software-based encryption that we accelerate with AES-NI. Scale, and on the big side, I get, what about the edge? Arjun has a question about what are we doing for the edge? One of the things that we're doing that's a bit, I guess, edgy, pardon the pun, is that we help customers like IBM transport data to the cloud. So you can also put QuantaStor on lightweight storage systems. They use a system from a company called Acromove that's got QuantaStor installed on it, and that's how they send really high capacity NAS boxes out to their customers so that they can shovel tons of data into those appliances and then migrate that to IBM Cloud Object Storage. So we do some things like that, but in terms of like IoT, we're more focused on sort of the back off, the back office or the data center side of it, where it's the aggregation point that we're focused on, the rack scale object storage that those IoT systems would be feeding. All right. So, that's the kind of the key advantages of scale out clusters. You get the 3 different protocols all available at the same time on the same media. This is showing a couple of different examples on the left. of some high density systems from Supermicro and Western Digital. You can manage multiple clusters within the same grids and then set up, you can do like bucket level replication between these, like example, these two different clusters can be put in the same grid and set up bucket level replication or backup policies to move files, the scalability, and you can also use the native CephFS file protocol for HPC use cases. So if you've got a need for render farm or different AI machine learning, you can use the native CephFS file system, which is a fan out protocol connection. So you can think of it like PNFS. You can have a client talk to all the different nodes simultaneously and really get to some really high performance numbers. For ransomware, the key thing that we've done is some improvements to our replication policies to automatically set up long-term retention rules. And so you can indicate how many snapshots you want on your source side and at your DR site. And by default, we put in 2 dailies, weeklies, monthlies, and quarterlies. So if they just took our defaults in setting up remote replication policies, they're going to have some snapshots that they can roll back to. And on the object storage side, we have an immutability, we have data governance modes. So you can set up that, and so that, if somebody tries to encrypt the file, it's just creating a different version of it. It actually hasn't deleted the underlying data. So the immutability is there on the object storage side, and our backup, our replication policies provide protection for the file and block storage by having long-term copies that you can recover data from. How do we discover the underlying hardware for compute and storage to be really composable and purpose just the right compute and storage without over provisioning in one side or another? That's another, Bertrand, that's a great question too. And that really gets into our strategy around composable disaggregated infrastructure. And that's my next slide. Next couple of slides are going to go into multi-tenancy and CDI. So I'm going to jump right into that next. So I'm going to hold that question, hold that thought. The scale up clusters, we talked about this. These are using ZFS underneath, and these are more for more compact, low cost footprint type things. So if you're putting a box in a remote for a remote office, the scale up clusters are more common because they're going to need less storage. You can fit upwards of close to 400 terabytes of storage in one of these 2U cluster in a box units. And you can, with a few JBODs, you can get to multiple petabytes and have that still fit within 10 rack units. So these are really great for a variety of different use cases. Veeam is a really popular way or use case for the high capacity scale up clusters, and VMware is our most common use case for the high performance NVMe. This here is using dual ported NVMe drives. So this looks like a single server at the top, but that's actually got 2 server sleds in the back. And if one of the server sleds is turned off, the pools automatically move to the other internal head node. So that's a really cool unit because it's one of the first units that provides us with the ability to deploy NVMe in an HA fashion. And those can also be combined with SAS media as well. So you can have highly available NVMe drives combined with high density SAS JBODs and do hybrid deployments that use a mix of nearline SAS and dual ported NVMe. This is just a slide showing some of the things that we've learned over the years on scale out performance. And this is object storage. And it used to be object storage was always considered slow. And nowadays, object storage can be really fast. And this is a good example. This is with just 2 trays of NVMe storage and 6 servers. And we're hitting in this testing that we were doing, this is about a year back that we were doing this performance testing. And we hit 17 gigabytes per second on that small configuration, and 9 gigabytes for reads and 9 gigabytes per second for writes. So the real key takeaway here is the linear growth that you're seeing in that graph. As we added additional S3 gateways to allow more and more clients to come in and more load, the performance just kept going up. So the cluster here is the same 6-node cluster, but what it is showing here is as we add more and more clients, everything just gets faster and faster. So there's more room here. We ran out of clients to keep adding, but even that with that 6-node cluster, I don't think we were out of gas for a little while here. If we had more clients to go connect to put more load onto those S3 gateways, I think that we could have gotten a bit higher on these numbers there as well. So really exciting to see that linear scalability that you get with scale out. And performance wise, we see roughly the same performance for our NAS, our scale out NAS as well. So yeah, really, really cool stuff. And there's a question here on that we are doing NVMe over RDMA. And yes, for the back end, when we integrate with like what you see on the screen here, the Western Digital OpenFlex Data 24, we are connecting to those using RDMA. That's going to give us the fastest performance. It's going to make that NVMe device be almost as if it's inside the server itself. So we're using RDMA, we're using lossless Ethernet configuration for the communication, you know, with the external JBOF with those. But QuantaStor, when you are consuming storage from QuantaStor appliances, you can access it over iSCSI and Fiber Channel, but today you can also access it over NVMe over Fabrics with TCP mode. So on the back end, we integrate with these NVMe over Fabrics JBODs using RDMA, but on the front end, we can go and redeliver storage over NVMe over Fabrics TCP. So yeah, it's really a cool technology. We haven't gotten that protocol yet certified, our NVMe over Fabrics with TCP certified with VMware. We're not really seeing people use it that much yet, but we've integrated it into the product because NVMe is just the way forward. As most of you probably already know, a lot of the manufacturers have stopped making SAS SSDs, and so they're fully transitioning over to an NVMe world. And so we've over the last few years have been doing a lot of work to bring QuantaStor forward with all the latest in NVMe features. So yeah, earlier there was a question about multi-tenancy. So I'm just going to go over, what is it, and then just take some questions on what we're doing with it. The general idea with multi-tenancy is that it solves the problem of how do you set up storage, like you see in the bottom. This is like an example of setting up like some QuantaStor storage clusters, and you've got some object storage that's set up as a cluster for US West 1 and East 1. We've got some file storage and some block storage. And we want to share that with 4 different companies, and these can be competitors. And so when they go and consume the storage from a common system, they really need to be isolated such that they don't even know that those other companies exist. And the way that starts is with VLANs. You go and segment your customers at a network level so they physically have their own network. And that's very commonly done with the cloud service providers by putting each customer on their own VLAN. But it doesn't really stop there. When you go to talk to a particular storage system, you can send commands like NFS show mounts, and it will show you all the different shares that are available, file shares that are on a given system. And you need to make that side multi-tenant as well. So there's a lot of technology that has to go into the storage platform. And what we're doing there is on the block storage, we map the individual devices to networks and VLANs so that when you are consuming block storage, those devices are only visible on those specific VLANs, and only then to those IQNs and that are registered for what we call your resource group or tenant. And so QuantaStor has this concept of resource group. I've written it in here as a tenant object. It's to make it a bit more clear. And so inside the grid, you go in and you make a tenant for each of these customers. You assign a VLAN to the tenant. And now you can put resources into those tenants, and they can only see what they've been assigned. And their VLAN keeps them separate, and the technology that we've put into the QuantaStor nodes around containerizing the protocols provides that extra layer of protection as well, so that even if somebody breaks into a container, they're actually not into the grid. They can't actually access anything except for the storage that was assigned to their tenancy, to their resource group. So the other kind of cool thing about this is that the security model that we developed, we patented a security model around multi-tenancy that goes and enables us to scope the resources to a tenant and scope their permissions to just the resources that are in there. So when you log into a grid and see our UI as a tenant, it automatically scales everything down to just what you've been assigned. So it's kind of neat. If you are at a company and you're in the finance department and you're the IT admin for the finance department, you can log into the grid, but you're only going to see the resources of the finance department. And that's kind of the next part of this, which is multi-tenancy is not just for cloud service providers. The really cool thing is that organizations are really, adopting much stronger security strategies today. They have to. There's so many problems out there with ransomware and other security breaches. They're really trying to compartmentalize all the different departments within their organization and their networks. And so here I'm showing, some different soda companies or whatever, but you can also think of that as different departments within the same company, being able to set up VLANs and serve those different departments and do chargeback accounting for those organizations. So where we are today is QuantaStor has these multi-tenancy capabilities, and that's heavily tied into our object storage. You can set up multiple object storage clusters and assign buckets and users to those storage from those different clusters. Our block storage has got VLAN scoping coming in the next rev, and then this summer the file storage gets an upgrade in our multi-tenancy for that through containerization of the protocols, so that there's an extra wall around that, and that's also going to give us the ability to have every tenant be in a different Active Directory domain as well. So we're really excited about where we're headed in terms of more advanced multi-tenancy features around protocol containerization. Yeah, there's a question about the vVol support. We've developed a VASA module, or vVol as it's called, for file storage, but we haven't published it yet. It's still in the middle of going through some certification work, so it got backburnered for a little while. All right. So how does multi-tenancy tie in with composable disaggregated infrastructure, and what is CDI? So what CDI is all about is disaggregating these core parts of a server. So whether the server is being used for compute or storage, you've got a CPU, that's the core heart of the server. You've got RAM and you've got storage media. And data center operators would really love to break these things out into 3 separate individual ingredients rather than having them packaged together. So if you think of it like raw ingredients that goes into a recipe, if you can separate them and have the raw ingredients on hand, then you can make anything that you want in the environment by composing those things together. So today there's companies building these dedicated boxes that just have RAM in them that allow you to dynamically map RAM into a server, or in the case of what we're focused on, dynamically map storage into a server. So what CDI for us, what the area that we focus on, is being able to take the storage out of the server and put it into rack units that are basically serving up NVMe over Fabrics devices. And now we can go compose storage clusters and add more capacity to them without having to modify the servers. And now the servers can be any model. It doesn't matter whether it has 2 slots on the front for storage media or 24, you don't need to put any storage media in it because it's going to be dynamically delivered over this NVMe over Fabric storage fabric on the back end. So that's super exciting, and it makes it so that you can get to much higher densities in the data center too, because now you can just start putting compute blades in there, or just, you know, blade type architectures in there, and the storage is coming in over the network through this storage fabric on the back end. So this, around this, we've done a bunch of work with Western Digital to make it so that within QuantaStor, you can assign storage from these Western Digital OpenFlex systems directly to QuantaStor nodes just through a couple clicks of a button. You don't need to go in and deal with multiple UIs or learn the command line utilities for these OpenFlex boxes. You can just say, I want to assign these storage devices to that node and these storage devices to these other ones, and totally build out a cluster just on the fly. And if you want to go and expand the cluster, you just go in there and assign more storage from these JBOFs, just a bunch of flash units that are on the network. So it's really exciting what we can do there. And as time goes on, we'll be adding even more orchestration to that, so that you can sort of auto-magically go from, hey, I've got X amount of capacity, go and completely deploy me an entire cluster with that, and QuantaStor will just do the right thing to go deploy the cluster in fewer steps. Today, we do that in a fairly small number of steps, as I'll be demonstrating next, because I think this is, we're down to our last slide here. Actually, right before I go to the demo, I want to show you guys a little bit about, well, how do you even design one of these things, right? That's one of the big things that our VAR channel struggled with software-defined storage. We've been growing our channel of value-added resellers and distributors over the years. We're up to about 85 VARs and disties today. And this was one of the things that consumed a lot of our time, consumed a lot of Joshua's time in Visio. Joshua's the Visio expert that he didn't want to be today. You know, nobody wants to have to go and change a Visio diagram 10 times just because somebody wanted to change the drive size around. So let me show you our design utility real quick. And this lets you go in and design a Ceph cluster without really having to have a lot of knowledge of Ceph or of storage. You can put in, say you want to develop something that's 5 petabytes in size. You just put the usable capacity that you need for whatever the workload it is, and then you choose what you're going to use it for. It's going to be like a large-scale archive for a library. You can choose that, and then you can just go and adjust the hardware. We've built into the design utility a lot of the modern servers that are integrated into the QuantaStor product. We don't put them all in here, but the most common units we put right in here. So let's say your reseller is an HP reseller. You can go and choose HP Apollos and design it around that. And then you can choose the size of the drive. Say the reseller says, oh yeah, the 20 terabyte drives are out. You can use those now. And then we go and adjust the amount of flash storage here that's going to be used for the metadata offload and write log offload. So this slider lets you adjust the amount of flash in the unit, but if you get it too low, you can see it gives you some warning messages down here in the device specification. So that's it at a really basic sense, how you can go and design a whole cluster, and then you've got your bill of materials and the information that you need to go get a quote from Darren. So yeah, this has been a game changer for our channel to be able to go in and design new systems, and customers can go in and say, oh yeah, my data is not compressible, let's adjust that. Or there's 11 nodes, can we bring that down? Can we reduce the erasure coding layout to maybe 5+3? And yep, there it goes down to 9 servers. So it's always making sure to reach this goal of 5 petabytes usable. And of course we can adjust that. And if there's any problems with the config, like we see here, where it's saying we need more flash storage, it's going to show that in red with a little message. So just a little tool that we make available for designing these scale out solutions. We have another tool that's almost identical for the scale up solutions. Performance and sizing. That is a great question, and it's our most commonly asked for feature for the design utility. And it's one that we're going to go sort out this summer. So we've been collecting a lot of performance data on different clusters, and we're putting that into basically a little equation so that we can forecast, what the performance will be like as you add more storage media to a scale up or scale out cluster. The kind of the short version, the general rule that we use for estimating performance is 70 megabytes per second per hard drive that's added, and 300 megabytes per second per SSD that's added to a scale out configuration. So if you design it around a platter-based configuration, we're going to accelerate that with some SSD, but you would just take 70 times the number of drives. So let's say you had, as a simple example, 100 drives times 70, it's going to do 7 gigabytes per second with 100 hard drives in there, and some NVMe flash added to boost the write and write performance and metadata access. If it's an all flash configuration with 100 flash devices, it'd be 300 megs times the 100, and you're going to be at 30 gigabytes per second. So yeah, you can really get to some great performance numbers. And as you can see in that graph I was showing earlier, that line matches with the 300 megabytes per second per SSD. Yeah, all right, let's
Steven,
yeah.
how are you guys managing support, maintenance, hardware repair, et cetera?
That's a great question. That's also been a challenge for software-defined storage in the past. What we do is we have a global support organization, and we take first call, whether the customer thinks it's hardware or software. We take the first call, and we involve the VAR that sold them the solution so that they can RMA equipment and keep them in on the loop. But we diagnose down to the metal. We want to have our organization not have the customer have to talk with multiple people to get the situation resolved. So we'll figure out whether it's a bad power supply or a bad hard drive, bad RAM, bad CPU, and then get that customer connected in with the VAR that's taking care of the hardware to go get them replacement parts and things like that. So we make it
don't necessarily replace the parts. You're using a global support like Support Services out of Atlanta or something. Who are you using for break fix? Repair?
Our support team is a remote support, the hands-on support to actually go replace a drive might be from Dell if you bought Dell hardware, or HP if you bought HP hardware. So you're also going to have a support contract with the hardware vendor. So if we do identify, hey, it's a bad power supply in your Dell R740, we're going to direct you to go contact Dell to go get that part replaced. And there's also some partners that we have like StoreTrek and EMEA that we partner with to provide on-site support for systems like Supermicro systems.
So, and then the second question is regarding implementation. Are you using companies like an Avnet Tech Services down to do your implementation before you ship, or are you doing it on-prem at the client's environment?
Usually it's happening at the VAR. So the VAR will typically have the equipment to their location. They will go and install QuantaStor, and they go through what we call sort of the early part of what we call our pre-go live check. And so it will go from the manufacturer of the hardware to the VAR or distributor. The distributor or VAR will then put QuantaStor on there, set the IP addresses per what the customer has provided, and then it will go out to the customer ready to go. So when they rack it, they boot it, QuantaStor is already pre-installed. And from there, they will have a meeting or a couple of meetings, depending on what their timing is like with our support team, and they will go through the rest of the pre-go live check. So they'll go through setting up call home alerting. They'll go through to make sure all the software is upgraded and setting up the pool with the customer, providing them with some training. So all of that is included with the software subscription. There's a question there also about our channel that Darren was speaking to, and we've got a global channel. You can order from our resellers around the world, and those are all listed on our website. So we have distributors like Supermicro and Equus, AMAX, Exertis Enterprise, and EMEA. And all of these distributors, they go, and as we were speaking to earlier, they go and pre-install the software on the servers that they are selling to the customer. So it comes as a packaged solution. In some cases, we've got customers in dark sites where they need training on how to install QuantaStor from scratch, because for security reasons, they have to install Red Hat first and then put the QuantaStor OS on top. So we also provide training on that as well. So depending on what their needs are, we might be going into some training using virtual machines in our lab just to kind of demonstrate, here's how to go through all that process. And we have a way of taking our package server that has all the new packages and putting that into a virtual machine so that they can take that and put that into a dark site and do upgrades without having any public internet access. All right. So can everybody see my screen? I've got a QuantaStor grid set up here with 4 boxes. And I just set these up with virtual machines. So you can see that the hardware vendor here says VMware rather than like Dell or HP or what have you. But the UI and everything is exactly the same for whether it's virtual machines or physical machines, and you can mix and match them, which is kind of a cool thing. You can have remote offices with their own NAS box, but it's totally just a virtual machine. So you don't have to ship them a box to go get some NAS to the remote office. Bertrand has a question here on how do we bill for the solution? And we kind of do some creative things there too. And this really, we do a lot to just simplify things for our channel. And the way that we do that is we say, sum up all of the raw capacity that's going to go into the grid, choose a support level, there's silver, gold, or platinum, and choose a subscription term. And that's it. There's no add-on cost for features. There's no add-on cost for using Flash versus Platter. There's no software features that you have to buy. If you know the support level, the subscription term, and the raw capacity, that's all we need to know to go and get a quote over to one of our VARs. And so we try to make it super simple that way. With this active subscription, the licenses are transferable to new hardware. So if your hardware servers are getting old and you want to move your subscription forward, you can just move that forward. We have 1 year, 5 year, 1, 3, and 5 year subscriptions. But for MSPs, we've introduced a new model that is a month-to-month model, and that was just introduced this year. So we have a pay-as-you-go model for MSPs. A good example of that is, let's say you're running an MSP and you're going to start using QuantaStor to deliver object storage to your customers, and you need to set up something like 2 or 4 or 5 petabytes of object storage to begin with. The MSP model is a pay-as-you-go model that also takes into account the amount of used capacity. So it's a usage-based model for those MSPs. So they don't have a bunch of out-of-pocket at the beginning before they have customers using the storage cluster. So that's a special model we've introduced today, or not today, but this year, just for MSPs. And we already have a few looking to use that model going forward. So it's really great. We've got our own license management system that lets us enhance it and do creative things to adopt these models really quickly. And IBM was the big driver for us in building out a sort of pay-as-you-go model, because all the way back in 2011, when we first started working with them, they said, we need a pay-as-you-go model. And so the first thing that we had added to our QuantaStor license server was a whole pay-as-you-go system. And now we're starting to add more features to that so that we can kind of break out of the basic model that we put together for IBM and be able to handle more complex cloud service provider scenarios. So anyways, yeah, that's how we do the billing or how we do the pricing. And it just keeps it nice and simple that way. Back to deploying a cluster. So this is what QuantaStor looks like. You can put in the IP address of any of the boxes. I've logged into the first one, but we can put in the IP address of the third or fourth one. Here we can put in 81 and log into this one. It's saying, hey, I've got to accept the certificate. And it's loading the UI right now. Our office is in a neighboring city, so we're kind of the UI has to load some of this stuff over the VPN. You can see, you just click on any of the systems and you can see some real-time stats, and everything is accessible from like right-click menus and the toolbar at the top. And the toolbar changes depending on what section you're on. So the features, the broad categories of features like multi-tenancy and those other things are distributed across the tabs at the top. And the grid dashboard is where you'd see the hardware. These are virtual machines, so it's not showing us hardware images there, but with real hardware, you'd start to see the front bezels of those systems and thermals and stuff like that. So what we're going to do today for the demo is create a scale out object storage cluster. And a lot of times folks are coming to our product, setting up an object storage cluster for the first time. So in the upper right-hand corner, we added a getting started button that brings up this dialog. So you can say, hey, I want to set up a storage pool for scale out object. And you can go here and it shows you all the steps that you need to go through from creating the cluster to, at the end, creating a bucket. So you can start uploading object storage to the cluster. And basically, we're going to go through these 6 steps. I'm going to not do that through the getting started because I want you guys to see a little bit more kind of like how you would do it through just the toolbars and stuff like that in the UI. But you can certainly just go directly and click the buttons in the getting started and go start to finish and completely set up the object storage and log out. So you don't need to have any knowledge of Ceph really to set up an object storage cluster or these different ones. It is good to have some basics, but our support organization, as part of the pre-go live check, would be going through this with the customer and asking some questions and providing them with training as part of this. So let's get started. We're going to click Create Cluster here and select all 4 of the systems and put them into a cluster. We can make multiple clusters, but we need at least 3 boxes to make a scale out cluster because we need to be able to have an odd number for a quorum so that we can have 3 or more monitors in the system. So minimum size for a cluster is 3 nodes. We've got 4 here. And then we can choose a different network for the client interface that they'll be using to access the storage via S3 versus the backend internode communication. But what we've been doing more often is making that one network because it's so much simpler to set up. It just requires that you have faster networking, and the cost of 100 gigabit Ethernet has been declining very quickly. And so our go-to now is dual 100 gigabit Ethernet that's bonded together. So that's how we typically set up new clusters these days. If you want to turn on encryption, you can do that here. You can turn on both software or hardware encryption. And we integrate with KMIT, so you can have your keys managed in a separate key server. So that's really nice for being able to manage your keys centrally, especially for large organizations. And if you want to turn on compression, you can just click there. We need to tell it about these systems outside of installing the OS and putting a license key in. There's nothing that's been done to the grid so far. So I haven't set any of the networking outside of just the default stuff that it got when the systems were set up by our automation system. So there we've created the cluster, and you can see the task running here in the bottom in the taskbar. I'll make this a little bigger and clear out the tasks that have finished. And this is basically going to go through and create a monitor and set up all 4 nodes into the grid. And this is going to take a couple of minutes. So while this is running, I'll show you some other parts of the UI and answer any other questions that you guys might have. But after the cluster is created, we're going to go here to add some media, add some storage to the cluster, and then we're going to create an object storage pool. And those are the 3 main steps of setting up the cluster. So now you can see all 4 nodes have been added to this new storage cluster within the grid. If we add more nodes in this QuantaStor grid, then we can create a second cluster and a third cluster. So you can manage multiple scale out clusters here. And we can see that the monitors are in an initialization state. The monitors are sort of the watchdogs of the cluster. So if a device goes offline, the monitor is going to detect that and let the clients that are connected know, hey, don't talk to that data device for a little while. It's been unplugged, or don't talk to that particular node for a little while and all of its services, because those services are offline. So that's the job of the monitor, is to go and monitor, as the name implies, all of those various services and to keep current with that. And that's why you have to have 3 of them or more, because if you have a monitor go offline, you immediately need another monitor to take over. And so when you connect to a scale out cluster internally, QuantaStor is doing some things to map in SMB and NFS and these other protocols. It's always key that you have 3 or more monitors. So QuantaStor does that for you. It's just automatic. All we had to do is say, make us a cluster, and it's going to do all the right things for us. And that's kind of the theme of what QuantaStor is all about. You need to just tell it what your intention is. Like, I want to add this media to the cluster, but you don't have to think about, well, how should I size the caching for it? How do I go tune for this and tune for that? It knows, based off of the detection of the underlying hardware, how to properly configure the cluster for you. So you just need to tell it at a high level, hey, I want these 4 nodes in a cluster, or make me an object storage pool. And it's doing all the tuning for you underneath. It's Ceph, but with a Ceph solution engineer built into the software. Okay, so we've got our monitors and our cluster created. You can see all 4 nodes, and you can see a monitor on each of these first ones. The next bit is these are going to finish initializing, and then we'll be able to start adding storage to the cluster. And let me show you how we add storage. So we've got a bunch of devices here. These smaller ones we're going to use for our data devices, and these larger ones here we're going to use as our cache devices. And we accelerate platter storage in 2 different ways. We accelerate it by putting a write log that's all flash in front of all the IO going to the platter, so that your write performance is just like NVMe. It's just like flash level performance when you're doing writes. And then we take the database, that the internal data block mapping information, the file system information for each of the data devices, the hard drives, and we offload that to flash as well. And so that's called the metadata database, and that gets moved over to flash. And so by offloading the write log and the metadata database that would normally be on the hard drive to flash, we're really accelerating the overall performance of the cluster. And that's a mandatory thing with QuantaStor deployments. Anything that's platter-based, we always have at least 2% of the storage for a cluster as flash. So now let me just double check. I think, yeah, all of our monitors are coming online now, and it's got a little warning on here because it's saying, hey, you've got a cluster, but you haven't added any storage to it yet. So we're going to do that right now. This auto config button is sort of the easy button for having the system just go and detect what's the best way to configure the storage that you have. And what it did was it took all of the data devices and it put them over here so we can use those as data devices. And it put all of these devices that were our flash devices that we're going to use to offload the write log over here. And what QuantaStor is going to do is make these into RAID 1 mirror pairs before taking and providing flash storage to the underlying what's called an OSD. So that protects it in case you lose a journal device, one of these SSDs, the journal device isn't lost. It wouldn't really matter if you lost both halves of the mirror pair, because then you would lose some OSDs, but you're not going to lose so many OSDs that you would lose data. But it's much more efficient to have those mirrored so that you don't have to replace OSDs, which can have a longer rebuild time than just replacing a flash device. So we always mirror the flash. And that's it. So here we're going to click OK, and it's going to start creating all those devices for us into the cluster. And so we're going to start seeing first those journal groups appear. So these are the mirrored flash storage that's going to be used to accelerate the OSDs. And now that those are all created, QuantaStor is going to be going in and adding the data devices and taking a little piece of journals storage as each new OSD gets added. So here's that first OSD and it is got a little piece of flash storage here that's a few gigabytes and a couple of gigabytes of flash storage for the write-ahead log. And so this is a flash accelerated platter device underneath at this point. So it's going through and making all of the OSDs. I've got 4 OSDs per node. You know, on a high density system where you've got like 60 hard drives and maybe 8 nodes, you know, you'd have 480 of these OSDs. So this is a really small configuration, but it's a great way to see how easy it is to go set things up. And whether it's a simple 12 drive configuration like we have here, or there's hundreds of these OSDs, these steps that we just have gone through are all the same. And so it's just that simple to go set up a scale out cluster. And I think the last, so once those OSDs are done, we go here to go create this scale out object storage pool. And here's where we choose what erasure coding level we want for the scale out object storage for the data pool. And more often than not, that's all erasure coding, because versus replica, you can choose between replica or erasure coding. But erasure coding is so much more efficient, and especially with larger clusters, we'll do like an 8+3 so that you get close to like 72% efficient with the space. You can see here that all of the storage has now been created and it's in an initializing state. It's going to take a minute or two for that to finish, and then we'll be able to create the pools. So it's a great time for us to switch over to the breakout room in case anybody has any other questions. I have demos of this on YouTube as well. So if there's some more detail, I've got like a 15-minute demo on YouTube. And if you are interested in setting up one from scratch, our licenses are available from our website. We have a community edition. You can download it and set up your own storage grid and object storage cluster. So, and here the object storage devices are now coming online and finishing the initialization setup of them. So, yeah.
Got one, Steven, from Bertrand in Paris. On your site, you present your solution for plenty of activity sectors, energy and utilities, defense, and so on and so on. Do you have the idea already to package or to bundle your offer specifically for some sectors to even still simplify the deployment of your solution?
Yeah, that has been something that we've been working on recently with Supermicro, because they have a need to kind of package a NAS solution specifically for like the education sector. So yeah, we've been starting to do some bit more bundles with some of our distributors like Supermicro and partners like Exertis, Hammer. So yeah, that's becoming a bit more popular, kind of getting something that's pre-canned for a particular use case. That's especially the case with the smaller configs. As things get larger, customers have more requirements and the environment gets a bit more complex, and that's where the design utility really shines, and being able to really customize it exactly for what their need is. And so those are still standard configs, but there's a bit more design work that goes into them versus just somebody that needs a fixed amount of storage for virtualization.
In many cases, just look at for a turnkey solution. That's why I asked you that. It's quite a simple way, you know. It's I take it it's 80 or 90% of my needs. After for personalization, I will see if I need it or not, and that's why today that's going to have this kind of turnkey solutions anyway.
Yeah. And like when IBM uses QuantaStor for their mobile appliance, They actually, when we have a special migration or mobile edition key that goes and turns off a bunch of parts of the UI. And you can actually go in and turn off parts of the UI for each individual administrator user and to kind of simplify it down to just a more basic NAS appliance, if that's what the use case is for. Because when you're, using it for a specific, purpose, a lot of times, like for a scale up configuration, you don't want to see the scale out tab or the multi-tenancy tabs or some of these other things. And those are all really easily turned on and off through a couple of checkboxes in the security tab for individual users. So, oops, I don't want to remove the user. I want to modify. You can just say modify user and customize, what tabs and sections of the UI are visible for a given person. So yeah, really easy to kind of customize it for specific use cases. And that seems like it's becoming more popular.
And my last one, it's also, do you will add more kind of a automation process in your solution? That means automatization, more and more automatization, deployment, monitoring, and so on.
Yeah, so you can fully deploy QuantaStor through, different Pixie boot install type mechanisms. There's I think Foreman and some other automation systems by which you can inject QuantaStor onto a server and do the full install. And everything that you see in the UI is accessible from APIs and our command line utility. We also have a QuantaStor Python client library. So every single thing is fully automatable, and we've got customers that use those in scripting to go automate creating snapshots.
It means that at big scale, I can write a Terraform script and to program QuantaStor to be deployed by this kind of programmable CI/CD.
Completely. Yeah, exactly right. And we put all of the documentation on our website at wiki.osnexus.com. So it's all public. There's no like authorization or password you need to get to the docs documentation for the REST API and the other things. So yeah, I'm sorry. We were in the middle of we went and got all of our devices added, and those are online. Let me kick this next step off because it takes a couple minutes as well. And here's where we're going to go create an object storage cluster. And we can name these sort of Amazon style. We can call this like US -East -1 and make this look like it's AWS from the customer's perspective. And this is actually really important for some products. Joshua was just recently helping a customer do a deployment using Veritas Net Backup product I used to work on many years ago. And it really required that the object storage look exactly like AWS. And so Joshua went and customized it like this to make it look like the AWS US East 1 region. And I'm just going to click OK, and it's going to go set up that object storage cluster for us. And we're going to see down here in the bottom that task is running. And I'm going to clear out the completed tasks again. And then when this object storage zone has been created, we'll be able to then go in and add what's called the S3 gateways. And that's basically putting a service on every one of the QuantaStor nodes that talks the S3 protocol. You don't have to have the S3 protocol running on all the nodes, but you definitely benefit from it. And so you can put a load balancer in front of QuantaStor, and the more S3 gateways you have running in the cluster, generally the more performance that you're going to get. And we see that very linear increase in performance with the more gateways that are running. You can even run 2 gateways per QuantaStor appliance. So with like 8 nodes, you could be running 16 gateways. And that just makes it so you can just really sustain a massive amount of object storage traffic concurrently, which is exactly what you need in larger organizations or MSPs, or even with like machine learning workloads. We've been doing some partnering with some other storage vendors to be able to go and put QuantaStor as the backend object storage behind high performance file systems as well. Yeah, so anyways, we're going to see the different component parts of the zone get created here. So this is a underlying Ceph pool that you're seeing getting created, but it's a component of the zone. And so at the end, QuantaStor is going to group all of these individual pools together and call that what we call an object storage pool group. And so you'll see a single icon over here with all these sort of sub pools underneath. And this data pool is where all of the data is stored. So when you're adding objects into the zone, all of the data for those objects are being stored in there. But the metadata is distributed into other areas. And the key pool here that's really storing all the list of all the different objects that are in a particular bucket is this index pool. And so for optimizing the whole cluster configuration, we have to put that index pool on flash storage. And the cool thing is that QuantaStor does that for you automatically. It takes a look at the type of media that's available in the cluster and just takes care of it. So we don't really need to think about any of those steps. But yeah, once this is done, it's going to take a couple more minutes for this to finish creating the object storage pool for us, and then we can create a bucket and kind of wrap up the demo. Is there? Let me bring up the chat window. Is there any other questions for now?
So there's a tab up there called Cloud Integration. Did you cover that and I missed it or something?
Yeah, I took kind of a narrow path through the feature set is the demo, because I didn't want to get kind of unfocused with it. But that's a great question, Kimberly. The cloud integration is how we tie QuantaStor into the public cloud. So what if you want to go and back up your files into the public cloud because you don't want to buy tape drives anymore? And we have customers doing exactly that. We've got, as an example, we've got a football club that goes and backs up their QuantaStor appliance up into Microsoft Azure blob storage. And so they've eliminated tape from their environment because QuantaStor just puts a copy up into the cloud for them. What's really kind of cool about that too is we made it so that it leaves behind a stub.
They actually haven't eliminated tape because that's what's stored. That's what blobs
right.
on, so which is pretty funny.
That's right. Yeah, like Glacier and Blob is actually tape behind the scenes. Tape will be around when we're all gone. I mean, it's just going to be around forever because it's so low cost. But at least the customer has eliminated their need to manage tapes, right? So they don't have to go and shuffle them around and put new tapes in and all that sort of thing. So so yeah, totally spot on, Kimberly. And but yeah, this lets us go and do backups into the cloud. And what a cloud container is it's a mapping of a bucket into the QuantaStor grid to turn that bucket into file storage. So now you can access your bucket as over the SMB protocol for Windows and Mac users, or the NFS protocol for Linux users, and start writing files using these native file protocols. And then once the container's there into the grid, we can now do backups from the NAS storage into the cloud container, and we've bridged to the public cloud. So it's kind of a two-step thing, bridging to the public cloud. First, we put the container in here, which is which bucket do you want to do your backups to? And the second step is creating the backup policy. So over here in the schedule section, you can go create backup policies. You can set up snapshot schedules. You can set up reporting schedules. Like, let's say you want a report sent to you via email on, hey, what's the overall health of the grid? How much free space do I have in my pools? You can get a nice summary executive report sent to you, periodically, so that you can keep tabs on what's happening in the grid with the report schedules. And I think, yeah, our cluster's all set up. So here you can see there's a bunch of internal pools that make up the zone, and but the kind of the two stars of the show are key pools that are storing all the individual data about individual objects is the index pool. We've got all the metadata, and the data pool has got all the blocks of data storing, your actual objects. You go and upload a 3 GB video. That all 3 GB is going to go into the data pool, and then a small piece of data into the index pool that's referencing that indicates the name and the other metadata about that object that was uploaded. So we've completely set up a Ceph cluster, added devices, created an object storage pool. We want to go and turn on the S3 gateway, the ability to go and access the cluster over S3. And we're going to just make that available on every node in the cluster. And that's the best way to do it. It's going to set it up with HTTPS by default. And I'm just going to click OK, and it's going to go deploy those for us. And so if I go up here to see the cluster, you're going to see some icons appear that represent the Rados gateway. There's the first one, and we're going to see those appear on the other 2 nodes. These S3 gateways, we deployed 4 of them. Those are going to take a minute to get deployed. And you can see QuantaStor is doing a bunch of this in parallel. So you can see now all 4 of them are deployed across those nodes of the grid. And we can start writing data. So we can start making buckets and assigning users to the storage. So I'm going to show you how to create an S3 user. So here, Camberly, it's an account, and I'm just going to put Camberly gmail.com and just make an example account and click OK. And we've created an S3 user. That's all there is to going and adding more users to the grid. You can see here that task is running to go add the account. And if we want to see what the credentials are, we just right click and we can view the access key. It generates one by default. And this is the access key and secret key, just like you would get from Amazon.com for an object user account. And you can add more keys and remove keys for the account. But what we want to do is make a bucket and assign it to the new account. So we're going to go to the storage management tab, go to the bucket section, and create an S3 bucket. And there's a bunch of different options in here. The main thing is the name of the bucket. We can call this like media archive or whatever we want to call the bucket, the user that we're assigning it to. We have some nice little things to pre-size the bucket depending on how much storage, how many objects we plan to put in there. So if you're going to go use it for Veeam and you're going to put 100 million objects in there because you're going to be using it for lots of backups, or 500 million objects, you can pre-size it so that there's no blip in performance as it adds more objects. What happens today if you don't pre-size it and you just make it totally auto dynamic is it'll, after you get enough metadata into the index for the bucket, it'll say, oh, I need to reshard this for more to be able to add more database entries. And you get a little dip in performance during that time. And so it's always good to pre-scale it. So we'll go pre-scale it. We'll turn on object locking so we can have the ability to lock specific objects. And if we want file access to the bucket, we can just check that box, and that'll give us NFS access to the bucket as well. And we can even batch create some of these. So if we wanted to create a whole bunch of buckets, this would just create it media archive 1, 2, 3, 4, 5, or what have you. So if you need a batch create, you can just increase that number. But here we're going to see the task start. It's going to run and create us a bucket, and then you're going to see it appear right there in the UI. And that's it. I mean, that's all there is to. We've completely created a cluster, added a user, created a bucket for the user, and you can now just come in through that user account and totally add more buckets and upload data, use that for Veeam backups. And so most of the day-to-day management of QuantaStor is really just going in here and adding users and making more buckets. The stuff that we did at the beginning around, you know, setting up the cluster and all of that was all you know, just kind of typically a one-time step until you're ready to go and add more media. We're seeing a little health warning on the cluster, so I can go over here and it's telling us that I've got 1 PG inactive, 1 PG peering. That'll sort itself out. There's usually a little time for this stuff to for the cluster to sort out once you set it up for the very first time. But most often what this is caused by is that we need to go and adjust the clocks and just do have it update with the NTP servers to go make sure the clocks are all sorted and up to date. Yeah.
Do you have to add the users individually, or can you do any batch import from pre-existing directories?
Yeah, you can. Everything's available through our command line utility and our REST API. So if you have like a file with the name of all the users, it's very easy to go and turn that into a script that just goes and puts all 1,000 or hundreds of those users into the system. You can batch create as well. So if you have like you just wanted a prefix with a number at the end, you can tell it to go batch create thousands of users at a time as well. So yeah, that's where the REST API, the command line utility, the Python library really comes in to just make those kinds of repetitive steps go away. Yeah. Any other questions? That's kind of all. Oh yeah, go ahead.
Let's say, Steve, there's a question that's come in and saying any intention of SNIA CDMI interface as well as S3.
Yeah, so we only focus on S3 today, and the reason why is that the CDMI didn't really get the legs that we all hoped it would. CDMI, for those that are unfamiliar, is basically an object storage protocol that was like an industry consortium that was put together to come up with an object storage protocol that would be sort of like not vendor specific, but effectively Amazon won that battle, and S3, which is the simple storage service at Amazon, is the de facto standard. And so everybody today makes what's called S3 compatible storage. So QuantaStor is S3 compatible storage. There's the Swift protocol that was also out there for a little while. QuantaStor technically can talk the Swift protocol as well, but we don't expose that through the UI because nobody's really using Swift anymore. But no plans to do anything with CDMI at this time. Maybe that'll become more popular in the future, but today it's just it's an S3 protocol world, and so that's where our focus is at, is doing more with that. All right. Yeah, great question.
Well, we have just over 5 minutes, so I would like to invite any final questions, any comments. I'd love to hear from anyone who does not agree with Steven. It's always interesting if a vendor, especially for someone like me who pretends I know what I'm talking about, but really I don't. So it's always interesting to hear from people who are more technical like you guys, to hear if you've got a different view. Not necessarily because Steven is wrong, but because you may have heard from other vendors who are taking a different line. Maybe because you've spoken to so many, you've created your own opinion, and it's not exactly the same as what you've heard. So if anyone has that kind of viewpoint, I'd love to hear that. And we promise we won't be offended.
I can add to that, Fred. We're actually doing a lot of collaboration with other vendors. I mean, we're working on a certification to use QuantaStor with Weka.io. We love their file system. They've really made the kind of the one of the world's fastest file systems, but they use object storage on the back end. And so we've got an upcoming deployment that's going to be using QuantaStor on the back end of Weka.io, so that we're really excited about. So those kinds of mashups we've done a number of times. I used to work with some of the folks that are at Pure and when I was at Veritas, and I'm very pleased to say that we've got some customers that are using QuantaStor with Pure on the back end. So where they've got Pure FlashBlades that are all block storage and they need file, these customers have put QuantaStor in front of multiple petabytes of flash storage from Pure to turn it into file. And they've got that across multiple sites. They're doing creative things with remote applications. So yeah, it's kind of neat the different ways that we are collaborating with other storage vendors and doing some really cool mashups that take into account some of the best of the different technologies from different companies.
I'm just checking back through the questions. Actually, there was, I'm not sure whether we did answer it, and then it was a question about Comprise, I think. Let me just see if I can find it.
Oh yeah, Comprise is a company that makes a layer over file storage so that they can make all your SMB storage look like it's one big file system. The problem is that they at least the version that I looked at a couple of years ago was really reliant on sort of some new features in the SMB protocol. So we tried to do some mashup work with them and couldn't make it work at the time. And maybe that's changed because the version of Samba that we're using internal to QuantaStor is newer, and maybe their tech has changed over time. But we haven't integrated with Comprise yet. It's some cool technology, but not an integration point for us today.
Interestingly enough, though, I was sort of thinking, Steve, we could add that we are doing quite a number of projects with StrongLink,
Yeah.
which I think that's probably a valid one to mention, as well as Strongbox, StrongLink as well.
Yeah, definitely. That's a great point, Darren. And they make some really cool technology. It uses a different approach than what Comprise does. And StrongLink is is a data mover, and it's also sort of that same kind of idea of put an abstraction layer over all of your different storage appliances to make them look like one, but they can move data between file and object, which is kind of cool. So you can archive and tier your storage. Another vendor that we've done some cool stuff with a major video game company is this Resilio. I don't know if you guys have heard of that product, but it's a replication technology. It will keep multiple sites in sync with each other. So if you've got engineers and developing software and artists around the globe, and they are producing content, you can have it replicate across your different QuantaStor boxes using Resilio. So you can put the software directly into the QuantaStor box. And we're working on technology to more tightly integrate Resilio into the platform and make it more modular, so we can put other systems into QuantaStor and do more tighter mashups in the future. So really excited about that one. That's some really cool technology that they have, and it's immediate. What's neat is somebody goes and writes a new piece of content for like a video game, and it will detect immediately that the file is written, and it will then immediately start copying the file as soon as the file is closed and it's not being actively written to. It marks that as for transfer, and then the transfer happens very quickly. So it's very easy with Resilio to keep every site really current, up to date. Yeah.